Okay guys, what we're going to do now is calculating parameters for a given situation. Now, this we already touched on back when we did chapter 5. Okay, so we did this already in chapter 5, but now we're going to do it incorporating also those inequalities that we've used in this topic. Okay, so for example, let's start by just talking about it. What we said back in chapter 5 is that we can look at where a parabola will sit, okay, based on its equation, okay? So for example, if we have our x-axis like this, okay, and I might make that a little bit longer. Okay, we know that there are 3 possibilities for a happy parabola. So for a parabola that has a positive a value, okay, that means the coefficient of x squared is positive. That means that our parabola looks like this, okay? So this is a positive parabola. Now, it can either be completely above the x-axis, it can be touching the x-axis, okay, or let me just make this a touch longer, or it can cross the x-axis. Okay, so this should be just recapping what we already did a few units ago. All right, now in the first case, where it's completely above the x-axis, we know that d, the discriminant, is going to be less than 0, okay? We know in the case of one which is touching the x-axis that d, the discriminant, is equal to 0. And we know that in the case of a parabola that crosses the x-axis, that d is greater than 0. Okay, how do we know this? Does anyone remember where the discriminant comes from? Remember that the discriminant comes from the quadratic formula, because we have a quadratic formula where x is equal to negative b plus the square root of d over 2a, or x is equal to negative b minus the square root of d over 2a. Okay, and this tells us the solution for where a parabola crosses the x-axis. Okay, so this is where y is equal to 0. Okay, this allows us to solve for y equals 0. Now, in the first instance, the discriminant is less than 0. Okay, so if we make a d negative, so we would have negative b plus the square root of negative d over 2a, you will remember that the square root of a negative is not possible. Okay, and that means there are no solutions. So no solutions. Okay, and remember this is for y is equal to 0. Okay, so this means that the parabola doesn't cross the x-axis. Okay, if we have a situation where d is equal to 0, then we get x is equal to negative b plus the square root of 0 over 2a. Okay, and the square root of 0 is 0, okay, which means that we only get one solution to this. Okay, in the third case, if we have a positive number, okay, that means that we will get both a positive and a negative answer to the square root. Okay, so we will get the plus the square root of d, we will also get minus the square root of d, and that gives us 2 solutions. Okay, Now, this is the case for a positive parabola, all right, for a negative parabola, and that means a parabola where our coefficient of x squared is negative, okay? That's a parabola that's sad, so the parabola is facing down, okay? Now, in the case of one of those, this parabola here is a negative parabola where d is less than 0, because again you can see that the parabola does not cross the x-axis. There are no solutions for y equals 0, because remember, on this line, y equals 0. That's what this line actually is, okay? The next parabola will be, again, a sad parabola, but it touches the x-axis, okay? And in this case, the discriminant is equal to 0 because there is one solution to the quadratic formula. All right, the third one is one like this, and this is a parabola that crosses the x-axis. So it has two solutions, and in this case, d is greater than 0. All right, these were our situations. Now, what we're looking at today is if we have a parabola in our function, what that does to this. Okay, so for example, if I have f(x) equals x squared plus 2px minus 3, okay, and we want to know where this parabola is, where this parabola has two solutions, okay, so where, for which values of p do we have two solutions? Okay, and if there are two solutions, that means that the parabola crosses the x-axis. Okay, so you could be asked in two different ways. Where do we get two solutions, or where does the parabola cross the x-axis? Okay, so we're going to calculate this. Now, we know that d equals b squared minus 4ac. Okay, in this parabola, b is 2p, okay, it's the coefficient of x. A is over here, and there's really a 1 there. Okay, and c is minus 3. Okay, so these are our a, b, and c. Okay, so b squared is going to be 2p squared minus 4 times a times c. Okay, so our discriminant in this case is equal to 4p squared plus 12. All right, now we want to have two solutions. So we know that if we have two solutions, then we have d is going to be greater than 0. All right, so we can now say that 4p squared plus 12 is greater than 0. All right, this is our first part of the solution. Now, we want to know what values of p we need though, okay? So in this case, firstly, we're going to need to isolate p. Now, we are now working with a quadratic equation here, okay? I know the original question was a quadratic equation. This is now another one, all right? So actually, there's going to be two ranges of p, or there's going to be one range where it's in the middle. We'll talk about that in a sec. So, the quadratic equation with an inequality, we know the first thing we should do is change the inequality sign to equals and solve it. So 4p, I don't know why this just moved. (4p squared plus 12 is equal to 0. Okay, so we have 4p squared is equal to minus 12. p squared is equal to minus 3, and p is going to be the square root of minus 3, or p is going to be the negative square root of minus 3. Now, we know that you cannot take a square root of a negative. So in this case, actually, we will never have two solutions for this equation. Okay, so this equation will never cross the x-axis. All right, it's not possible. And that's our answer for this one. So that's one scenario that you may come across. So there is no solution. Therefore, this parabola will never cross the x-axis. Okay, now that means we know we had a happy parabola. So if we draw a little sketch of that, that means that our parabola looks like this, and it will always look like this. Okay, no matter what value of p we choose, it will never cross the x-axis. Okay, let's try another one. So f of x is equal to 2x squared minus 6x plus 4p. Okay, so this is going to be our next one. Now, again, we want to know, let's try the same again. So what values of p will give two solutions for x? Okay, that means again we're crossing the x-axis. All right, so again, let's look at the discriminant. D equals b squared minus 4ac. Okay, now in this case b is minus 6, so we have minus 6 squared minus 4 times a, which is 2, times c, which is 4p. Okay, minus 6 squared is 36, minus 4 times 4 is 16, times 2 is 32, so 32p. Okay, so this is our D. All right. Now we know here that we wanted two solutions for x, so we know that D is going to be greater than 0. So 36 minus 32p is greater than 0. All right, we just need to solve this. So 36 is greater than just 32p. Okay, and we can say p, we have 36 over 32 is greater than p. Now we need to simplify this. Okay, this is not neat and tidy. We can divide both of them by 4. So 36 divided by 4 is 9. 32 divided by 4 is 8. It's greater than p. And we always finish off with p on the left. So p, and we flipped the p to the other side. We then also need to flip our sign. So p is less than 1 1/8. Okay, so for any value of p that is lower than 1 1/8, we will get two solutions for x. Okay, and our parabola will cross the x-axis. So if p is less than 1 1/8, then we get a parabola that looks like this. Okay, but this will be p is less than 1 1/8. Okay, if p is greater than 1 1/8, it will be above the x-axis. So here we have a sketch like this. If p is greater than 1 1/8. If p is equal to 1 1/8, then our parabola will touch the x-axis. Okay, and we're done.